Good morning, everyone. This video is about the project presentation of a project that I have done in my internship uh, internship in Emertxe Institute. My name is Mahesh Gunaswani and the project name is IoT based home automation. Let's get into the presentation first. Before discussing about the project, first we need to know about Internet of Things, that is IoT. Internet of Things refers to a network of physical devices, vehicles, home appliances and other items embedded with sensors, software and connectivity, allowing them to connect and exchange data with each other over the internet. This interconnectivity enables the devices to collect and share data, providing valuable insights and enabling a range of applications such as smart homes, smart cities, and industries. Automation, IoT technology has the potential to revolutionize the way we live, work, and interact with the world around us. Let's discuss about some of the features of IoT. It has IoT has some features like unique objects connected to internet. It means we can connect unlimited and infinite number of devices using over the internet. Here devices, not people. Here we are connecting devices but not people. By using these devices, we are able to communicate with each other. And next is bidirectional communication. It means we can communicate from both the sides, from client to server, server to client. And large complex data flows. It means a huge amount of data will be transferred you over the internet. New types of insight. It means that has never been before. Uh, we can develop new items based on using of Internet of Things. Nowadays, Internet of Things has huge demand, huge boom. The reasons why Internet of Things has this much boom is hardware is getting cheaper. Nowadays, hardware is getting cheaper by cheaper. We can see that even resistors, even capacitors are coming at even 1 rupee each. Next, machine-to-machine solutions are mainstream. Connectivity is proliferating. Software is more advanced. It means software is getting day to day more advanced, and we are developing new softwares so that we can connect easily to each and every device. Now we'll discuss about the requirements. We need many devices and large scale security requirements so that we can protect our data and volumes of data end-to-end integration. Next, we need to discuss about embedded systems. Any combination of hardware and software which is intended to do specific tasks. It means here we are integrating hardware and software both so that we can perform a specific task. If we take the example fitness trackers and mobile is also an embedded system, but PC is not an embedded system. The components that are required in embedded systems are microcontroller or microprocessor or SoC. SoC stands for system on chip. Next is memory. Next is sensors and actuators. First, we need to discuss about microcontroller. A microcontroller is a compact integrated circuit designed to govern a specific operation in an embedded system. A typical microcontroller includes a processor, memory, and input or output peripherals on a single chip. It means even a microcontroller is also consists of microprocessor. It needs some memory and also consists of input and output pins so that we can connect to external devices too. In our project, we use Arduino Uno as our microcontroller. Next is memory. Memory can be divided into two types. One is ROM, next is RAM. ROM stands for read-only memory. RAM stands for random access memory. In ROM, we can write only once, but we can read infinite times. That means we can read any time at any requirement based on from using the ROM. Now, next is non-volatile. It means it does not require any power to retain data. Once we store the data in ROM, it no longer requires any power to retain data. It means if we turn on power or turn off power, it doesn't require any power. We can access any time at any place at any time. Next is RAM. RAM stands for random access memory. Here we can read and write infinite times. Next is data is volatile. RAM is volatile. It means it needs power. Once power is off, the entire data stored in the RAM gets erased. Next is sensors. Most of the sensors produce analog output, but microcontrollers can understand only digital signals. So we use ADCs. ADC stands for analog to digital converters. Next, actuators. These actuators convert electrical energy to mechanical energy. Some of the remaining embedded components are human interfaces, FPGA or ASIC. ASIC stands for Application Specific Integrated Circuit. Diagnostic boards, cooling systems, so that we can cool the systems. These are all the about embedded system. Now let's get into our project explanation. How this project is about home automation. By using this project, we can control the brightness of garden lights using LDR sensor. We measure temperature and display it on CLCD. CLCD stands for characteristic LCD. Based on threshold temperature, we can turn on and turn off the heater and cooler using mobile application remotely. Then we will also measure the volume of the tank and display the volume on the LCD, and we can turn on and turn off the inlet and outlet valve using the mobile app. Whenever the volume of the tank is less than threshold value, the inlet valve is automatically turned on. This is about simply about the project explanation. Now let's discuss about the tools required for this project. The tools required are integrated development environment, that is IDE. We need at least require one IDE so that we can write the code and compile it. Here we use Arduino IDE. Next, simulator tool. We use PiximLab, our simulator tool, so that we can execute our code. We can execute it in this simulator tool. PiximLab consists of many PIC microcontrollers, even Arduino, PIC boards, many boards. Next, we use Blink IoT. This is a mobile app to control our hardware remotely. It is Blink IoT is a cloud also. Next is the peripherals that we require. First is LED. We need an LED light emitting diode, and we need LDR sensor, light dependent resistor, LCD liquid crystal display. Next is the temperature system. Let's discuss about each peripheral individually. First comes the Arduino Uno. The Arduino Uno board is a small programmable device that can be used to control sensors, motors, lights, and other electronic components. It comes in different shapes and sizes with various capabilities and features such as Wi-Fi capable, Bluetooth, and Ethernet connectivity. Arduino Uno is widely used in this. We can connect Arduino Uno is not an IP capable, so we use an Ethernet Ethernet device so that we can connect over the internet. Next is Arduino Uno is widely used in various applications including home automation, robotics, wearables, and IoT. Its simplicity and flexibility and affordability make it an excellent choice for prototyping and developing electronics projects. Next is peripheral is light emitting diode. Light emitting diode is a semiconductor device that emits light when an electric current is passed through it. LEDs are used for wide variety of applications from lighting to displays. LED operates in two states. One is forward bias, second is reverse bias. When positive terminal of power supply is connected to positive terminal of LED, then LED is turned on. This is known as forward bias. Then reverse bias. When positive terminal of power supply is connected to negative terminal of LED, the LED is turned off. This is the reverse bias. To interface LED with Arduino, we use two functions in Arduino IDE. One is pin mode. Pin mode, it requires the parameters like pin and mode. It is a built-in function in Arduino IDE to set any pin as input or output. Based on this function, we can set any pin, either input or output. Next comes digital write. It takes the parameters like pin and value. To set this function is used to set the value to the pin. Next peripheral is CLCD. CLCD stands for Character Liquid Crystal Display. It is one of the variant of LCD, most commonly used to display ASCII characters. Customization in symbols is possible here. Their CLCDs are usually small in size and low in power consumption. make them ideal for portable devices such as calculators, digital thermometers, and handheld game consoles. So CLCDs are mostly used in many applications too. In our project, we use CLCD with I2C. I2C protocol uses two lines. One is serial clock line and another is serial data line. Serial clock line is used to connect with clock of microcontroller. Each microcontroller will have some clock frequency. This serial clock line is used to connect the CLCD with that clock frequency. Next, serial data line is used to transfer data from from microcontroller to CLCD. Next, we need to initialize the CLCD to interface with Arduino. First, we need to follow some steps so that we cannot interface with the Arduino. First is lcd.init function. This is used to initialize the LCD. Next is lcd.backlight. This is used to turn on the backlight of the LCD. Next is lcd.clear. It is used to clear the screen of LCD. lcd.home. This function is used to set the cursor at the first position. Next comes the analog and digital converter. ADC is one of the important peripheral in embedded systems in real-time activities. Any microcontroller can understand only digital values, not analog values. But most of the sensors produce results in analog only. The Arduino Uno has in built-in ADC. We can connect to A0 to A5 pins but not to G5O pins. Steps in converting analog to digital values. First step is sampling or quantization. Here we break down the continuous signal to discrete signal. Next is encoding. After converting to discrete signal, we will assign digital values to each sample here in encoding. Then it convert to the digital signal. Here we use in Arduino IDE we use a function called analog read, which takes a parameter pin. This function is used to read values from the specified pin in analog form. Next comes about the pulse width modulation. This is a technique used to achieve average voltage to vary the active time versus inactive time in fixed period. Mostly used to control average voltage of the load connected. This technique is widely used in applications like motor controls, lamp dampers, audio, power controls, etc. For this, here we use a Arduino IDE. In Arduino IDE, we use a function called analog write, which takes the parameter spin value. This function is used to write an analog value to a pin. So we can write a value to the pin here. We use this technique to control the brightness of the LED based on analog values produced by the LDR sensor. In our project, we can control the brightness of the LED using the LDR sensor using this pulse width modulation technique. Next is the temperature system. The temperature system here we use in our project consists of temperature sensor, a heater and a cooler. The temperature sensor is used to read the temperature of the atmosphere. The heater is turned on whenever the temperature is less than threshold values. It means when we will assign some threshold value. Whenever the temperature is less than that, we'll turn on the heater, and when the cooler is turned on whenever the temperature is greater than threshold values. Threshold values. Next comes the serial tank. The serial remote tank is a tank simulator controlled by serial communication protocol. It means it uses a serial communication protocol. So by using this, we can control the serial tank. The tank has several sensors and actuators that can be read and controlled using the communication protocol. In our project, we connect serial tank and Arduino IDE Uno using virtual pins. We use virtual pins through Blink IoT app, Blink IoT Cloud, and we will connect this Arduino Uno and serial tank. Here in our we use a virtual serial tank which has a volume of 3000 liters. We use some specific functions for the serial time. One is serial.begin, which takes the parameter speed, nothing but baud rate. This function is used to set the data rate in bit per second for serial data transmission. This is nothing but the what amount of speed that we require to transfer the data. Next is serial.write. This writes the binary data to serial port. This data is sent as byte or series of bytes to send the characters representing the digits of a number. Next, we need to discuss about the Blink IoT Cloud. This Blink is a popular Internet of Things or IoT platform that provides a mobile app and cloud-based infrastructure to create and manage IoT projects. The Blink mobile app allows users to control and monitor connected devices remotely using their smartphones. Blink also offers a drag and drop interface to build custom interfaces for IoT projects without any coding knowledge. Blink offers a range of features including real-time data monitoring, push notifications, email alerts, and cloud data logging. Using this Blink IoT cloud, we can monitor the data using the mobile application, and we can also get notifications. We can also send email alerts, and we can also perform many operations using this Blink IoT cloud. It also provides a secure connection between the mobile app and the IoT devices using SSL or TSL encryption. Blink has become a popular choice for hobbies and professionals alike to build and manage IoT projects. This Blink IoT cloud is used by many people, many professionals for building IoT projects. Next, this is about the presentation. Next, we will move to code Arduino IDE, where we have developed our code, and we will discuss here about the each and some topics about how we have used some functions here. This is the main file, home automation blink control file. Here we use here we link many functions so that we can perform the desired task. This LDR sensor. This is the file that contains about the inform that contains functions about the LDR sensor, and this is the header file for LDR sensor. This is the main header file. This is about the serial tank file. This is the header .h file of serial tank. This is the temperature system file, and this is the temperature system header file. First, we will discuss about LDR sensor file. In this LDR sensor, we have included some header files like ldr.h. Next, first we have declared one function called init underscore ldr. This function is used to set the garden light as output pin. This pin mode here we are assigning the pin as output pin. Next, void brightness control. This function is used to this function is tells about the how to control the brightness of the LED brightness using the LDR. First, we will take analog read of LDR sensor. Using this LDR sensor pin, we are reading the analog input, analog values, and this is the ldr.h file. Here we are declaring the macros, that is LDR sensor is connected to A1 pin and garden light is connected to third pin of our Arduino Uno. Next is the main.h file. Here we declare the macros and virtual pin that we connect here. Here if we observe, cooler V pin is connected to V0, heater V pin is as declared as the V2 pin, and inlet outlet V pin to virtual pin 5. And this is on we have declared as 1, off is declared as 0. This is about the main.h file. Next is the serial tank file. Here init serial tank void init serial tank. This function is declared. This function tells about the initial declaration of our serial tank. Here we have to observe serial dot begin of 19,200. This is the border out of the speed that we declare for so that the data is transfer is happens in bits per second. Next, this is unsigned into volume. This function is used to display or return the values in return the volume of the tank. Next comes the void enable inlet. This function tells about how to enable the inlet valve. Next comes void disable inlet valve function. This function tells about the how to disable the inlet disable the inlet valve. Next comes the void enable outlet valve function. This function tells how to enable the outlet valve. Void disable outlet, which takes the parameter void. This function tells how to disable the outlet valve. This is about the serial tank file, and these are all the macros about the inlet valve. That is, inlet valve takes the 0x00. These are the initial values that we need to declare before getting it before in for interfacing with the Arduino Uno. These are all the functions we need to declare in this .h file that we use in main file. Next comes the temperature system. In temperature system, we use this void init temperature underscore system, which takes void as a parameter. This function is used to set some initial parameters, like first we declare heater and cooler as output using pin mode functions, and using digital write we are setting them as low. Initially we are turning them off. By using float read temperature function, we are reading the temperature, and we are taking this temperature reading using analog read function from A0 pin. Next comes the void cooler control function. This function is used to control the cooler. Based on the control value, we are able to turn on and turn off the cooler using digital write function. Next comes the void heater control. This function is used to control the heater using control the heater. Based on the control value, the heater is turned high or low using this function. This temperature system.h file contains all the functions that we declared in our temperature system file. And now let's move to the main file. This temperature system home automation blink control system. Here we this three lines declare about the blink IoT cloud. Each blink IoT cloud will have authentication token. Next comes the hash include SPI. These are all the header files that we need to declare. This blink underscore write cooler vpin. This function is used to turn on the cooler whenever required, and we need to based on this function we will display the values on our CLCD. Same comes with the heater vpin. When we turn on the heater, this function will help us to display when the heater is turned on our CLCD. This is the about the inlet valve pin. Whenever we turn on that inlet valve, the it is displayed on our, it is virtually turned in our mobile application, and also on our also displayed in our CLCD. Next, this void update temperature reading. This function is used to update the temperatures after every 1 second. After every 10 values per second, we can update the temperature values per 10 values per second. Next comes the void handle temperature function. This function is used to read temperature and compare with 35 as our threshold. We kept 35 as our threshold value. When temperature reaches above 35, then the heater is off. Then the heater is made off, and it will be displayed on our CLCD too. Next comes the void handle tank. This using this function, we are able to control our tank inlet valves and outlet valves. Whenever the tank volume is less than 2000, and inlet valve is also turned on, or inlet valve is also turned off, then we enable the inlet valve so that it does not so that the tank will be filled, and we will turn on our outlet also. This is the void setup. These are all the initial functions that we declare to turn on our LCD, and so that we can put our cursor at the first position. We can print whatever the values that we need here. This void loop function, it controls about the brightness, some of the functions that we declared before, and we need to run each and some of the functions that we need to run them in loop manner. so that they can run continuously and we can produce our results. This is about the code explanation in which is, in Arduino IDE. Let's move on to the demo of our project. This is the Pixim lab. This is our Pixim lab. Now I have already run the code and I have uploaded in Pixim lab. Now I'll just show the now I'll just show it on how I can control using this. We need to take our serial remote tank also. Yes, I have connected our Arduino Uno to COM1 port, and now I am connecting our serial tank to COM2 port. I am making it. Now let's connect it. Yeah, you can observe that first we are controlling our LED using the LDR sensor. If you decrease, you can observe that if you decrease the LDR sensor resistor value, the brightness of the LED is getting decreased. Voltage value of the LED. If you increase the LDR sensor value, the LDR brightness also getting increased. This is the CLCD. This is the LDR sensor. This is the LED. This is the temperature system. This is the uh, Ethernet that we use to connect to the Arduino Uno over the internet. Now let me mirror my screen mobile. This is the Blink IoT app that in my mobile application. This is the widget that shows about the home automation, and here it is showing two tabs. One tab is one the tab one shows about the it has pin uh, virtual pins like cooler, heater, and temperature gauge. This is the temperature gauge. This is the widgets, and this is the notification bar. In tab 2, in tab 2, we have the widgets like inlet valve, outlet valve, and also the volume. Now first, I will turn on the heater. You can observe that the temperature here and the temp is shown in the temperature gauge. Whenever the temperature reaches 35 degree above 35 degree, then the heater is off and we got a temperature notification like temperature is above 35 degrees Celsius, turning off heater temp turning off heater. Now shall we first we will turn on the cooler. Now I turn on the cooler. We can observe that the temperature is getting down and it is also displayed in our temperature gauge too. And we can turn off the cooler too. It is showing us cooler off. Now once again I will turn on the heater. It is showing that heater is on. Now again I will turn off the heater. It is showing heater off. On the temperature on the CLCD we are displaying temperature and the heater is on or off, cooler is on or off on the first line, and on second line it is about the serial time. It shows about the volume and it also shows about whether inlet is on or off or outlet is on or off. This is about first about the temperature system. Now let's move to the tab 2. First I'll show it here. Now first I will turn now it is showing volume is 3000. It means the tank is full and inlet flow is off. Now I will turn on the outlet valve first. It is showing that outflow is on and the volume is getting decreased. and it is also displaying in our gauge meter. You can observe here. Now I'll turn off the cool. Now I have turned off the outlet valve. It is showing outflow is off. Now it will uh, now when the volume is less than 2000, it shows it the inlet valve will be automatically turned on. You can see inflow is automatically turned on when the volume is 2000. When the volume is below 2000, and it is showing inflow is on. Now I will turn off the outflow, and it shows outflow is off. Now, as the inlet valve is automatically turned on, the volume is increased. After the tank is full, the inlet valve will be automatically turned off. You can observe the inlet valve is automatically turned off, and the message is also shown here. This is about the project demo. This is everything. Thank you.